Okay, students, welcome. We'll discuss about 2.4.11 packet trace activity, modify single area OSPFv2. Okay, so we have three routers, the internet connectivity is there, web server is there, three switches, three PCs. All the PCs are connecting to other PCs, and PCs also connecting to server. Okay, OSPF is configured with hello interval for each interface as 10 second, dead interval for each interface as 40 seconds. Okay, hello interval means the uh, hello packet are sent between each routers, no, for establishing connectivity, neighbor connectivity. Very fine. Okay, dead interval 40 means it will wait till 40 seconds to make sure that there is no hello packet received. So we have to drop the connectivity or neighbor would not be there. Okay. So what we are doing is we are going to do two things. Okay, part one, modify OSPF default settings, verify connectivity. Second part. So modify default settings means I told you by default we have 10-second hello interval, 40 seconds for dead interval, and here also we'll change the bandwidth of each link. So before we start the part one, test connectivity between all devices. Okay, so I'll open PC1. I'll try to connect to 6400.1.2 first. Okay, I'll open PC1. Sorry, PING 64.100.1.2. Built-in, the first packet will fail because okay, that is done. Reply is coming. Now what I will do, I will change the interface R0 0 bar S0 bar 0 of R1. Its hello interval change from 10 to 15. That interval change to 60 from 40. So I need to see the interfaces. See 0 bar SC 0 bar 0 between R1 to R2. This I want to see the interface name. So not go to options, preference, then always show port label. Comes out option. Go here. Now go to R1. Enable config space t int sc 0/0/0. Then IP OSPF hello interval. It is by default of 10. I'll make it 15. And data interval also I will change from default 40 to 60. It's actually 4 times hello interval. Okay, 15 into 4, it will be 60, right? So interval, I'm not using tab key. I want to type the full command, but you can use tab key now. It's okay, 60. So after doing this, what happened? The neighborhood, it will not be a neighbor. So R1 will not be a neighbor because here it is hello interval 15 and dead interval 60. In this R2 SE00, it is still 10 and 40. So we need to check that. See, neighbor interface, neighbor down because it is changed. Now what I will do, see, they ask you to, after short put connection, noise connection is R2 fail. Now what you should do, you have to configure the settings, adjust the timer on R2, same like R1. So go to R2 SE00 because that's the interface connecting R1 R2, right? The same, go here, enable, configure, space the interface SC0000. Okay. Then IP OSPF hello interval 15, IP OSPF dead interval 60. Now once you click this fast forward, they will become neighbors again. See, yes, done. Adjacency is done. Okay. Now what's next is the bandwidth settings. Okay, I want to change the bandwidth of SE00 interface. Okay, so before you change the bandwidth, no, I want to trace the route of PC1 to server. Which path PC1 takes to reach the server? So I'll go here. Okay, go to command prompt. So trace RT is the command to check the or trace the route to where server 64 to 100.1.2. Okay, see that path. It takes the first one 172.16.1.1. That is actually 172.16.1.1 is R1 G0 browser. So first PC1, if you want to go to 6400.1.2, first you reach the gateway 172.16.1.1. Okay, next it will go to 172.16.3.2. What is 172.16.3.2? This one, R2 SC00, and it will go to R2, this router R2. Next is 209.165.200.226. This is the internet. So 209.165, this one internet. Okay, it will go here, then finally reach here. So the PC1 takes the path PC1 R1 R2 to 6400.1.2. Okay, I want to change this part. So what should I do? I want to change the bandwidth. Okay, so before that I'll tell you the bandwidth and the cost of interface are inversely proportional. That means if bandwidth is high, the cost will be low. Bandwidth low means cost will be high. We'll check that. Okay, I'll go to R1. So I will go to R1 and I'll type the command, sorry, show interface SC000. I want to check the details of interface SC00. Okay, check that the bandwidth is 1158 kilobits per second. This is the bandwidth. Okay, and what about the cost of this interface? Okay, the bandwidth is 1158. I want to check the cost. Okay, for that the command is show IP OSPF int SC 0/0/0. Same interface. I check the bandwidth. It is, what's the value? Bandwidth 1158. It is very, it's a value. Okay, high value. Okay, what about the cost? To check the cost, I put show IP OSPF int SC00. And I click like this. Okay, I could see the cost. There is a cost is 64. Okay, the cost is 64. So high bandwidth, cost is down. Okay, low cost. Now what I will do, I am going to change the bandwidth of the same SC00 to 64, not 1152. I am going to make this bandwidth of SC0 as 64. How to make this? Go to configuration mode, interface, name SC0/0/0. I am going to change the bandwidth. By default, the bandwidth was 1158. I want to change this value to 64. Okay, bandwidth value 64. Okay, after this I will come out and I will check whether the bandwidth changed for the interface and what is the cost. Show interface SC0000. Now what happened? The bandwidth is now changed. Okay, bandwidth will be now 64. Let me check where is that. Okay, 64. See, now it was changed from 1158 to 64. Now what about the cost? So how the command is show IP OSPF interface SC0000. Now the cost has become 1562. So this is now too costly, more cost. Okay, earlier when it was bandwidth was 115, this one. Okay, when it was 1544, the cost was 64. But now when the bandwidth is 64, the cost has become more, 1562. I need the link with low cost. Okay, so what I will do, I cannot take this path. Now what the PC will do, which way the PC will reach this server? Let's see the trace route. Okay, now I will do that same trace route command. Now see how it goes, which path will take. It is going to 172.16.1.1, same router. Then it is going to 192.168.10.6. Where is that 192.168.10.6? It is R3S00. R3S00. And it will go to PC1 R1, not R2 because cost is more. Because I changed the bandwidth, cost is more. Now the PC1 reaches server via PC1 R1 R3 then R2 like this. Why, Mister? Because you can check the cost of SE001 because that's the one connecting to R3, right? So when I open this one, show IP OSPF interface SC 0/0/1, check the cost. Okay, the cost of the interface is 64 compared to the SC00. The cost was high. Okay, whereas the cost, that cost was actually more. We discussed, right, that cost for 00 was more because the bandwidth was less, right? So this 001, the cost is 64. And what about the cost of 000 IP OSPF INT SC 0/0/0? The cost is 1562. So we will not choose, the machine will not choose this path, it will choose S1, R1, R3, R2, this one. Okay. Now again, connectivity, you can try, all the PCs will ping each other. Okay, this is what the activity 2.4.11. Hope you understood. So remember one point, the default hello interval is 10 and dead interval is 40 seconds. I changed to 15 and 60, means the other link which is connecting to other router, that also should be changed, otherwise the neighbor, they will not be neighbors. Again, the default bandwidth, okay, it was 1544 something, I changed that into 64. So once the bandwidth is high, cost is less, but once the bandwidth is low, cost will be high. So the machines will choose the link with low cost. That's why they choose PC1, R1, R3 this way. Okay, that's it. We'll see in the next video.